All right, welcome everybody to Product Spotlight. What a great show we're going to have today. Super excited to bring all of this to you. This is going to be a day where we talk about our trip to London. One show today, we're going to be releasing a video tomorrow and one on Friday, both at 10 a.m. Eastern. So look forward to seeing that as well. So this is going to be a lot of fun being able to share with you what other people are doing from across the pond. I think it's going to be super exciting to share with you today's video where we're going to talk about parametric design. We're also going to be talking about generative design in this conversation. Howick had us over across the pond, as we like to say here, just a few weeks ago. And we got to tour London. We got to tour all around England. We got to go to all kinds of different job sites while we were there. So super excited about that for sure. For sure. So, all right, you guys just sit back, relax. We are going to be able to bring all of this to you live. We're going to talk about how is digital technology enabling architects, engineers, owners, and contractors to deliver better in terms of speed and scale. How is Bryden Wood specifically helping others hit targets around quality, safety, and carbon reduction around the world? We were on location in the Bryden Wood office in London. Dave Cooper, myself, and Phil Langley, head of creative technologies, talked through the platform's approach of DfMA and the projects where Bryden Wood is bringing the digital and physical together like the Forge in the newly opened Elizabeth Line Tottenham Court Crossrail station. The Crossrail is one of Europe's biggest modern infrastructure projects that finally opened in May 2022. And Tottenham Court Road is set to be one of the busiest stations, not just on the Elizabeth Line, but across London transport network, offering an interchange with a capacity of 170,000 passengers every day. So we want to say thank you to Bryden Wood for allowing us to be there, but we also want to thank our sponsors, Howick for making this all possible, for bringing us across the pond, as we say, to showcase what we are doing with steel around the world. If you haven't seen any of the Howick machines for light gauge steel roll forming, you're really missing out. All of these projects that we'll be showcasing in some shape or form has used their machines to take it to the next level. So a big shout out to the team for having us come over and do that. Nick Cobre, Cindy Pussman, Dion Anderson, and the rest of the team at Howick. You guys were awesome. Thank you for hosting Steel Horizon event. We also want to thank our other sponsor, Ben Hershey, and the team at Forward Solutions Group for helping Dave Cooper Live drive these conversations on construction innovation. So without further ado, let's get into the video that we did in the interview with Phil Langley. Here you go. Hey everybody, this is Dave Cooper, and we are at the UK headquarters of Bryden Wood in central London. And sitting with me is Phil Langley, head of creative technologies. Phil, thank you for joining us.
Thank you for having me.
All right, so this is exciting that we're going to talk about what the head of creative technologies does at Bryden Wood today, because you guys are doing things that others haven't even thought of doing yet and speeding up the process and what we do. Can you tell us a little bit about your role and what that involves here?
Sure. Yeah, I lead the Creative Technologies team, which is our specialist computational design and software development group. And we make software. We're not really software developers by background. We're all architects and engineers with a passion for the built environment, but also, yeah, a huge kind of commitment to digital technology and changing the industry through software.
So when you say changing the industry through software, how is technology really driving this industry forward, and how are you using it here at Bryden Wood?
So I would say a typical use of technology in AEC space is like using it to help an architect or an engineer design a building. Our approach is really to shift that use of software much earlier in the process, engaging clients and customers in the development of those technologies and the use of those technologies to make their projects much more intelligent, much smarter, much earlier in the process.
So when you say much more intelligent, much earlier in the process, why? What is change? What are you changing that other people aren't doing already, and what is the reason for that change?
So a big focus for us is design automation. I think that over all the years of the AEC industry, lots and lots of design intelligence has evolved in the heads of engineers and architects, and that's often constrained, and clients and customers aren't able to access that. So we want to share that knowledge, share that know-how with clients that have really big pressures to deliver large programs of buildings, whether that's buildings or infrastructure, at speed, at scale, around the world. So how do you do that? How do you make sure that they're able to achieve those goals and also hit targets around quality, around safety, around carbon reduction? And so what we're trying to do is encode those kinds of requirements as early as possible.
In the technology you're using, you said something earlier that was interesting to me, that you're designing software that normally the AEC community would use, the professionals in the community, but you're designing it so that the average person like myself could actually go in there and start using the design.
Absolutely, that's really critical to what we do. We've done projects where we made software for a school design in which children were able to design their new primary school. And that's kind of maybe the most extreme example of it. And we have projects that are much more technical than that, much more, I would say, sophisticated. But it's fundamental to that. I want my mum to be able to use it, really, and to design a building or a piece of infrastructure. And I think there's a way of genuinely democratizing design through this as well. I think it's about transparency as well as inclusivity.
So with the new design software that you're using, we were talking about generative design, parametric design, what other?
Well, we use procedural algorithms as well, but I guess our approach is it's very agnostic to those kind of terminologies. What we're really interested in is finding the right solution to deal with the problem that we encounter. We don't have a preconceived idea necessarily of exactly how software addresses a particular need. We're very open to what that could be. We have projects that use different types of design automation algorithms. We have projects that we deploy to web applications for scalability and other things that are more in-house and desktop use. So we're very, very open to what that could really be.
What is the value to what you're doing here to the end user, if you were to kind of sum it up?
Quality, intelligence, speed.
And predictability.
That's what they get out of it, really. Yeah, they get to take a huge degree of ownership about their design and delivery process. By pulling all of the digital technology up front, you create this kind of golden thread of data for them. So a lot of the clients we work with are owner-operators of their facilities. So the bit in the middle of building it is just an inconvenience. That's the bit, they need that to go away. It's not their business model. The upfront decision-making is tied to their business outcomes, and then, of course, in operation. That's fundamental to them. So what we're trying to give them is an ability to have an upfront digital twin of their existing assets and connect the two things together, kind of planning and operations.
Right. So outside of the AEC, the stakeholders of the company have more control of their project because they know all the bits and pieces up front all the way through the deliverable.
Exactly.
And that includes everything from what the sustainability factor is, what the predictability factor is, to what the cost, of that project is going to be.
Absolutely, and also how that project will operate within the wider collection of buildings that they run. So yeah, that sort of transparency, if you like, that ability to make better decisions.
Right.
And I think that's really fundamental to it. Like a lot of the clients that we deal with, they're dealing with big projects across a huge kind of geographic areas and lots of variabilities. Right now, economically and all sorts. And so how can they kind of be agile to respond to those kinds of things as well? And not really go into these kind of projects blindfolded or in some way with their hand behind their back. Right,
so using the software, and we're gonna get in a demo here in a second, you can make real-time changes.
Absolutely.
And the speed of the changes, the speed of the design, I mean, it's literally real time, it's fast.
Absolutely. I think that, conventional design processes allows for some design exploration, some kind of iteration. But of course, as a client, you're paying for that each time as well.
Right,
So
right.
the idea here is that, can you use the technology to create a solution space of many different possibilities, and then choose the right one, and change when it's digital, not when it's physical.
Right. Well, there you change when it's digital, not when it's physical. I like that, because the reality of it is if you can control all of this up front and you can get your teams to look at the process up front, then the benefits, the cost savings, the sustainability, the predictability, and the speed to market is all on the backside and happens much quicker.
Absolutely.
Right.
I think one of the things that we talk about a lot in design automation, people get very excited around the idea of optimization, but I don't really like talking about it like that. It's more like negotiation. All of those factors that you just mentioned, they're often in conflict with each other, and you're trying to make decisions on how to best balance those pressures. Right. And I think that's what we try to give to the clients up front, the ability to make those decisions and to understand those pressures and deal with them in a better way.
Sure. Well, let's look at a demo here. What are you getting ready to show us?
Okay, so this is Prism. This is our open source web application for designing housing and residential buildings. So this allows anybody to come up with a residential scheme that is encoded with design for manufacture logic. So we spent a significant amount of time capturing the rule sets around existing DfMA products from manufacturers and building those into the application. So typically, you'd spend a lot of time researching that as an architect or an engineer trying to design your building. Right. But what we're trying to do here is put that know-how into the tool itself, so that whatever you do, you're getting feedback on how plausible it is for you to deliver this building with modern methods of construction. So this is a site, it's actually in central London. You can nearly see it from the window of the office we're in right now. And there's a couple of buildings on here already. You can see these are the different typologies that we have in the app. So linear apartment buildings and tower blocks and things like this. And the app is parametric. So you can see this linear apartment building here. I can just grab hold of that and modify the layout of this building.
Just by dragging it?
Yeah, just by dragging these endpoints. So it's a linear building, so I can change all these things. And you can see on the left-hand side, we have an analytics panel, which is updating against the metrics. So whether that's the apartment type or other metrics around square meterage or the type of system that you're using. And you can really drill into the detail of the design as well. So it's not just a kind of block model. Actually, we have very detailed information that sits behind this.
So if I can ask you, so when you're moving that around, structurally, room sizes, bathrooms, or whatever's in that building, MEP chases, all adjusts automatically when you do that? And it's adjusting for modern methods of construction design. So whether panel, modular, whatever that may be.
Exactly.
Got it.
Exactly. So you can see in the detailed view here, we've got all the apartment layouts, and they're all kind of linked to those design for manufacture rules.
Okay.
So as I'm changing the apartment mix, and I get to choose whether I want 1 bedroom, 2 bedroom, 3 bedroom, how they're arranged around vertical circulation, I'm getting all this feedback. I'm getting like little alerts that are telling me what's working, what's not working. It's not a kind of system where the computer says no. It's always trying to work with the human as well as the machine to sort of give you that feedback to help you make better design decisions. And I can also start exploring the kind of system that I want to use. So I'm going to choose a volumetric system here and try and populate the design with modules. So you can see that across all 3 buildings, the system has worked out the range of different sizes.
So it's color-coded based on the size of each module that would go in that section, based on the interior walls, chases, sandpipes, all that.
Exactly. And I've got all sorts of different metrics coming out here. And the feedback it's giving you is saying, you could build this out of this array of modules, but maybe you want to design it so that you have more, less variation.
Right.
Maybe that's important. And different manufacturers have a sort of different impression of that. But the idea is, you can just kind of mess around almost with all of these different possibilities.
I mean, it's really drag and drop.
Yeah, absolutely.
Technology, right?
Absolutely. Okay. And then we get very simple feedback: red, amber, green. What's good? What's bad? Is your floor-to-floor height acceptable?
So it's telling you in real time what you have to look at, because it may or may not work, is what the system's saying. There's a conflict somewhere. Exactly.
And I think the reason it's open source actually is, first of all, is to get designers up to speed with what modern methods of construction and DfMA can achieve, but also to push manufacturers to say, hey, look, your products maybe don't deliver as much variety as you claim, or maybe you can push your product development, your system development in this direction and respond to those designers' needs. So it's really about bringing the two parts of the design and delivery process together in a piece of open source software.
You said something I think is very interesting, right? So if I am a stakeholder, a builder, a developer, somebody that has a project, and I want to use modern methods of construction, this gives me the ability to still use my engineers and architects that I have, and this system helps them walk through that process without them having 100 years worth of experience or their 10,000 hours.
Absolutely. And I think that I think that there's a possibility for different types of use of it. So yeah, my mum can use this and design a building at a certain level of resolution. But if you have a bit more knowledge and a bit more know-how, you can get into the details. So for example, on screen here, this is one of the apartments. So I can choose to micro-edit wall positions.
Inside the apartment.
Yeah, exactly. And then populate through that change through into all the building designs as well. So
it'll recalculate every floor, every level for weight loads, all of those things.
Exactly. And I think that we have podium settings, we have basement, which might not be the thing that you really get into on the first pass of a feasibility study, but the second iteration, the third, as you work through that process, you can do all of that within the tool, and then you're comparing many different iterative designs against each other with that that well understood metrics, consistency, the transparency, and back to what I said before, better decisions. So you get to choose which of those negotiated pressures you want to deal with best.
Right.
And, in order to deliver the project with design for manufacture principles, what do you really need to do to achieve that? This is what the tool is trying to tell you.
How long does a project take to do it this way versus the traditional way? Let's say we had a project like this. I mean, I know that would be years of design and development for an engineering and architectural firm, probably.
So I think that, the first feasibility pass of this, you can literally do in less than 10 minutes.
Say it again, 10 minutes?
Less than 10 minutes.
Yeah, okay.
And that gives you a certain level of information. The output of the tool allows you to bring that into the kind of more everyday proprietary BIM tools and things like this to work up the design. But, producing 10, 20 feasibility studies, early stage concept designs with that level of data, it's not just that it would take longer in real life or in your manual design, it's people don't do it because it's just not really possible. Whereas you get all that data for free. And you can price it, right? Like you can cost it.
Because it doesn't cost anything to use this.
No, exactly.
It's open source.
Exactly.
And so you said something about BIM. All of this that I'm designing within the software, I can export that into my architectural design software, BIM or whatever I'm using?
Absolutely. That's really fundamental to what we do in the team and the software that we build across all of our projects. We're not trying to replace those kind of everyday tools that designers and engineers are familiar with. We're trying to augment them to add the extra layer of intelligence. Those tools are good at what they do, and they're generalized tools for everybody. And what we're trying to do is create something very specific at the front end that kind of turbocharges those.
So this can really take years off the design process of a complex building.
Absolutely, and this is an open source tool which tons of different people and different organizations use, and you can shorten your design process. You can understand better what you should be doing fundamentally.
I know it's going to come up somewhere in a question. Tell me, how do you get the data in here from the manufacturers or the MMC or even the site plan we were talking about? Like, how does all of that populate into a system like this?
I mean, well, the geographic data, so the buildings and the map that you see on screen, that's the easy bit, right? There's a bunch of open source data that we can pull in. There is closed source data which you can buy and pull in. That's just a technical question. That's easy. Getting the rules out.
Easy.
Well, it is. Getting the rules out of humans is a bit more challenging. There's a real kind of cultural change about capturing those rules and sharing them. So the manufacturers that we spoke to during this project, they were quite reticent to share what their constraints and design rules were. But in reality, they were more or less the same between manufacturers. Their USP was not that the product was unique itself. It was more the way that they manufactured it. That was where their competitive edge was. And I think this idea that the design know-how that we're trying to encode into these technologies, that somehow that represents, that should be a secret. I think that's a big problem. And we spend a lot of time speaking with humans. A lot of software development that we do, is just about talking to people and trying to understand what those rules are. Taking human know-how and turning it into something that a computer understands that's a very different kind of activity than designers are normally used to.
It's a different activity and it's a different thought process.
Yeah.
So you're trying to change the mindset and culture of an industry that's always done it this way.
Yeah.
To look at it differently and realize that it's going to help them be more successful, deliver more projects in less amount of time, which is great for everybody, especially with the homelessness and the housing affordability issues. All of this plays into the bigger picture.
Absolutely, and I think that housing in particular, there's so much kind of contextual design that is required, and we're not trying to replace that. Actually, what we're trying to do is allow designers to use this tool to automate a bunch of stuff that can be automated, so that they can focus on the real value add that they bring. Architects focusing on placemaking, for example, and a better quality built environment rather than paperwork.
Yeah,
and that's fundamental to what we're trying to do. There is no project that we've done that automates everything. There is always the balance between what the engineer, the human, is really good at and what the computer's really good at.
Right.
And we don't try to kind of blur that line too much.
But if you can get 90% of it,
absolutely,
and that's a big speed up process right there.
Absolutely. And then then everyone's focus is on that last 10%, making that really, really great.
Sure. All right, so this is one of the programs that you're using here. You have others as well.
We do have others, yeah. We've got quite a few others. I'm going to flip to a completely different scale and context of one of our projects. This is called Rapid Engineering Model. This is about design automation for transport infrastructure, roads predominantly.
Rapid Engineering Model, REM.
Yeah, REM, with apologies to Michael Stipe.
Yeah, so, all right, walk me through what this is.
So the origin of this project is the design of roads in the UK, the Smart Motorways programme in particular, which is a highly productised and standardised way of expanding the UK's road network. So it's existing roads that are basically being enhanced for increased capacity. And we were asked to look at this from a digital point of view. We've never designed roads. No one in our entire organisation, I think, has
ever designed a road.
No, and which actually is very useful in this kind of context, because you kind of walk into it with a complete, childish naivety. So you sort of walk in and go, "Why do you do it like that?"
Right.
And so
you start thinking of it differently.
Yeah, completely. And sometimes you're just completely wrong, and sometimes you actually bring something totally different that's of value. And so, as we spoke to the client, we understood that there was a considerable amount of rules, considerable amount of standardization within the products that are being used, and therefore, this should be something that could be automated. And so, over the last 4 or 5 years, I guess, we've been developing this with National Highways very closely with them. And this is probably the most extreme example of flipping this kind of the paradigm of engineers and architects having the design control and giving it instead to the client. So they're delivering a number of these schemes every year. So they're typically, 20 miles, 30 miles long, hundreds of millions of pounds. They're doing a large number of these every year. It's a 5-10-year program. And so they need quality across their schemes, they need consistency. Safety is obviously a really big factor. So we built a bunch of design automation tools that would suck in a bunch of data, as you mentioned before. We're taking, not just open source data in this case, environmental data, LiDAR captured topography data, road alignment, existing assets, all of these things is kind of soup of...
That's already out there because it's been surveyed and shot.
Exactly, we're pulling it from different sources, turning it into something that's usable in the rapid engineering model. And that becomes the field against which we can automate. So this is actually a real road. Everything in this model has been placed automatically by our software. So
even the signs,
everything, everything. So there's the only human intervention to this is me rotating it right now,
and it takes in accountability for drainage and everything else, right?
Absolutely. So what we do is we pick up all of that context data, so environmental factors, topography, all road curvature, all these kinds of things, and we analyze the whole road for suitability. So where is a good place to build? In this case, a gantry, the sign that you can see here. Where is it good from an environmental point of view? Where is it good from constructability point of view? From a maintenance point of view? And and then position them against the rule set. And our rule set's obviously about safety and visibility and all these kinds of things. So we're trying to choose the best position for each of these construction interventions along a very long project in terms of time as well as physicality. So what you see on screen here, we didn't design the gantry automatically. That's a product. And fundamental to all of the tools we build is the ability to have the existence of that product catalog.
But you can reach to that, to that client or supplier or manufacturer, and they'll provide you the data.
Exactly. And
to scale.
Exactly, and this is the real product that they use. There's a bunch of kind of technology that goes with it, cabinetry, cabling. There's drainage, as you mentioned. All of these things. You can see that. Hopefully, you can see this retaining wall structure that's cut in. That's automatically designed as well.
In there.
Selected
based around a set of parameters. If this happens, then that happens.
Exactly. Very simple. Actually, very simple decision tree. So this project involves a whole different range of algorithmic techniques. There's some procedural, there's some parametric, there is some generative, and there is some very simple decision tree logics as well. And I think that's also fundamental. Like, as I said before, it's not one size fits all. Everything is kind of project specific, and we build it up in layers. This was not an overnight piece of work. It took a long time to kind of evolve the sophistication of it, I guess. And we're able to now design. I'll zoom out. Maybe you see a bit the scale of this particular project.
Well, just walk me through like the red, the green. That's cut and fills. Is that what is it?
The red and green. That's a good question. The red and green is really it's risk. So against all those different types of data that we pull in, we're analysing the road in 10-metre segments to understand how risky it is or how impactful it would be to have construction activity there. So, for example, in the embankment, you might have the requirement for a lot of cut and fill. And you don't want to do that. That's where your cost is. That's where your time goes. You might have an environmental factor that's where you can't. There's a huge impact if you construct in that area. There are safety factors to do with the curvature of the road, the visibility for drivers to signage. So all the colours that you see along the road, that's what the computer's reading. So we take all that data, like maps and all this kind of stuff that you and I could interpret and understand. We turn it into something that's machine readable. And so, this kind of...
And color-coded, right? So the colors would tell you how far you are from a sign before a curve. So if you needed 100 yards or 100 meters or whatever, then it'll point that out to you. Or say you don't have enough, you need to straighten the road here another foot.
Exactly. And that's really the way in which we're able to iterate through tens, hundreds of different possibilities of layout, and to get to a better outcome from safety point of view, from carbon point of view, from constructability and maintenance point of view. The kind of in all of our projects we have some version of this red, amber, green color coding, and it's really the pivot point between that human know-how into something that the computer understands.
The digital know-how.
Yeah, exactly.
And I would imagine, you can make changes fairly quick on this.
Yeah, absolutely. So for context, you can see how long this road is.
Sure.
This is pretty extensive. It's not even the biggest one we've done this, but this takes about 8 hours to generate this level of information.
So as long as you have the data to pull in for that area, you're telling me this takes about 8 hours to generate.
Yeah, exactly. And that would take months and months and months of manual design to get to this level. And within that 8 hours, we could generate maybe in parallel, 5, 10 different possibilities.
And the accuracy of these models.
It's more accurate than
you can hand draw it.
Yeah, for sure. And it's completely transparent. It's evidence based, so you can see every single. It's not a black box. Especially in a project like this, you don't want to have a situation where nobody understands what the computer's doing.
You
have to be able to make it transparent and understandable, because it's public infrastructure. It's serious stuff, right? And so you don't just want a computer says yes or no. I don't really know why. You've got to have access to that. So actually, we have thousands and thousands of pages of documentation that we developed with the engineering team at National Highways, so they understand all the decisions the tool is taking for them. And then the last 10% of it is with humans in the room. Very often, the rules that we've encoded, they conflict. So you need to meet this requirement, but actually it conflicts with this one. So the computer never tries to resolve those. It just flags them and says, hey, Dave, what do you want to do here? And then we have the kind of big room methodology. get inside the tool, drag the things around, and decide. And that's all traced in the digital thread. It's in the database. It's stored.
There's a blueprint of it all.
Exactly. Exactly. And so you know all of the decisions that were taken, and you can look back at it in 6 months, 3 years, 20 years when you finish the project, and make sure you knew why you did everything.
Or why something happened, or
exactly.
look at the data and go back to it.
Exactly.
I mean, I see such value in this, not only for the DOT, Department of Transportation, or highway management. Wow, maybe we could do a project on budget and on time. But I think on the other side too, when you're doing a lot of these large development sites, you got to put infrastructure for roads in and transportation. So I could see this playing in that realm as well.
Absolutely. I think that we've applied this in tons of different road contexts in the UK, not just these big, long highways projects, but as you say, those smaller complex roads that get in the way of the building, right? And things like this. But we've also applied the same kind of digital tech and method to different transport infrastructure problems. We've done it for rail, we've done it for London Underground recently at different scales. The same methodology that we're using in Rapid Engineering Model, we've just developed a tool which is automating the layout of cabling in tunnels, which from our point of view, same problem. Yeah. I've also never designed railways, so we kind of don't care if it's roads or rail.
Right.
Can we apply the technology in different contexts?
You're not designing the train, but you're designing the infrastructure.
Exactly.
The infrastructure is predictable.
Exactly.
Got it. So we're getting ready to head out of here to Tottenham Court and the Forge. Talk to us a little bit about how maybe this technology has played a role in both of those projects.
Well, Tottenham Court Road station's part of the Elizabeth line, recently opened. Bryden Wood, we were responsible for the construction information, design for manufacturer information for the tunnel lining system, which is super cool. And it was a hugely kind of complex...
tunnel lining?
Yeah, so it's GRC concrete panels, double curvature. I actually went to go and see it on Friday myself. It's wicked. It is. It's great, actually. And when you look at it, you think, wow, okay, this looks kind of, this is beautiful, it's perfect. You don't really think how, as a normal person, you might not normally think how it's kind of put together, but that process was incredibly complex for the team, and to have a kind of digital backbone to it was critical for them.
Right.
So all the panels in all the stations we worked on, there's variations to them, there's differences to them, and you need to control that parametrically. And you need to be able to generate the design information for regulatory sign-off by the client and also for manufacturing purposes, and deal with the changes and kind of, I nearly said bumps in the road, but I guess bumps in the rail that come with any of these transport infrastructure projects. So we're using design for manufacture software, SolidWorks, to control parametric models of every single component. So from every small kind of nut and bolt all the way up to the large kind of GRC panels. That's directly linked to construction companies, procurement process. And so the whole thing was nose to tail.
So tell us about the Elizabeth line.
Well, it's a major new railway line through central London and beyond, running east-west. Bryden Wood, we were involved in the DfMA for passenger tunnel lining system, which is a GRC concrete system, double curvature, super cool. And the project itself for us is a great example of the kind of physical and digital design approaches that we have in the business. The design efficiency that was realized through the physical design process was then leveraged through very sophisticated digital modeling in terms of the 3D models of the fabrication models that we created, as well as then linking all of that to procurement systems. So it was a real kind of end-to-end delivery, actually, and I don't think it would have been possible in the time frame that we were given to deliver that level of detailed information across the number of stations we worked on without that real kind of connection between physical and digital design.
And that physical and digital design, again, just to go back to what we were talking about, it speeds up the accuracy of the project, the sustainability, all of these things. So it's allowing you to move much quicker, which is less impact on the environment, less impact on the population that's waiting for those trains or has to use those trains. I mean, there's a whole lot of that falls right after that.
Absolutely. I think that we were able to reduce material weight hugely,
Right.
which goes directly to sustainability. Also goes directly to maintainability. So we're able to simulate all of these things through the software, simulate the construction methodology, simulate the maintenance methodology, reduce the number of people that were needed to install and maintain these things, which again leads to ultimately reduction in disruption in ongoing terms, and to make the whole thing safer. I mean, it looks really cool for sure, but it's more sustainable, it's safer and was delivered much more quickly than it could have been. And it was really an agile process too. The way that the team worked with the 3D, it meant that they could kind of suck in a point cloud scan of the tunnel as it was finished and adjust the model at the last moment, just to make sure there was no clashes, to make sure that there were not going to be a problem on site. And I think that ability to wait for that information rather than just, hey, we made all these panels, I hope it fits. It was not like that at all.
Right. I love it. So you can go in and scan it and get the points and know exactly what's good, what's not, or where you need to adjust. All right, and then we have the Forge. Tell me about the Forge quickly and how technology played a part in that and is playing a part in it during the actual build.
So Forge, again, it's another great example, I think, of Bryden Wood physical and digital design coming together. So it's a PDFMA building platform designed for manufacture. So the superstructure, it was...
So it's a multi-story building.
Yeah, it's a multi-story office building. No, it's a multi-story office building in central London. Also very cool. And yeah, we've applied our PDFMA system knowledge to the delivery of that building. So the superstructure, the cladding, the services engineering, all of these things have been conceived from the bottom up, the ground up, to be more efficient materially, to be more efficient in terms of productive processes for installation, and to be a better performing building. And so the digital part of that has been within the capturing of the product set. So whether that's superstructure elements, bracketry, or cladding elements, or MEP elements, and automatically being able to generate that model from the emerging design. So the superstructure model, actually, we built software that would automatically generate all of the connection details, all of the bracketry, all of the manufacturing information that was needed to deliver the superstructure.
Sure.
Again, super quick, better decision making, and intelligence earlier.
Right. I mean, I think it's just super impressive. So here we're sitting in central London, right? But you guys are a global company. You got a new office getting ready to open up in Boston and the United States as well. So for those out there, this isn't just here being used in the UK or London. It's actually a global operation that you can work anywhere.
That's right. Yeah, we're already spread around Europe and the rest of the world, and it's super exciting to make the steps into the US as well.
I love it. There you have it, everybody. I am sitting here with Phil Langley, Head of Creative Technologies, Bryden Wood. Thanks for watching. All right, everybody. Hope you enjoyed that interview with Phil Langley and Bryden Wood. We were over there for an entire week. We have more videos coming out. We're going to release one tomorrow, 10 a.m., and another one on Friday. Wait until you see the new Tottenham station and what they did there. 27,000, that's right, 27,000 unique panels. They had to use 3D technology. They had to use different types of molds to do everything. And it's quite an impressive project to boot. So with that said, again, I want to say thank you to Phil and also the team at Bryden Wood for having us over there and giving us the behind the scenes look, including Felicity McCain, Jamie Johnson, Nick Krube, Cindy Postman, Dion Anderson. In fact, the entire team at Howick Ltd for hosting this series as part of their Steel Horizon event. And also a big shout out to Ben Hershey, Forward Solutions Group, as well, for always supporting us in this show to help drive these conversations forward as we continue to grow and shout. Big shout out to my good friend Paul Cardis. What's happening, Paul? It's good to see you. Thanks for letting us know you were out there today. I hope everybody, to include Paul, is enjoying this information. We are leaving Saturday to go back to Switzerland for another European tour. So we're going to be doing our show from over there. The timing is maybe a little bit off because we're in a different time zone, but check us out while we're in Switzerland. We're going to bring you all kinds of great content from that as well, and a whole bunch of more content from London, England, and all around, because there is so much for us to learn. We are falling behind in this country when it comes to some of the technology, the offsite construction, industrialized construction, whether it's panel, modular, CLT, doesn't matter. We need to catch up. We need to build it better. We need to take our game to the next level, and we need to make construction great again and bring people back into this industry. Paul Cardis, if you don't know Paul, that's a guy that's actually doing that on3 technologies. You want to talk about a different way of learning using VR, AR, virtual glasses and hard helmets that can talk to you? Well, wait until you see some of this stuff. We'll be working hopefully with Paul in the future to showcase more of their products and what's happening out there as well. All right, everybody, that's a wrap for today. Thank you so much for tuning in. Stay tuned. Again, we'll release another one tomorrow, and we will bring all the latest and greatest to you from around the world, because that's what it's all about. Let's collaborate. Let's work together. Let's build it better. I'm Dave Cooper. We'll see you next time. Bye now.